Okay, so Mark Heim here, founder of Disaster Doc. Welcome you to module number 3, natural disasters by the numbers. Now, I don't want you to get too freaked out when we're talking about by the numbers. You know, people are either numbers people or they're not. So we'll kind of ease into this, and also we'll kind of conceptualize this in large groups for you so you can understand these numbers. They'll make sense and we'll look at them. But we really have to use numbers because we measure these things, right? If it's not measurable, it's not science. So we really want to take some time now, measure this, and look at what's really happened over the past 50 years. So I'm going to go through natural disasters over the past 50 years in terms of numbers, and then put that into context for what that really means for us. So let's talk through the learning objectives. After completing this lesson, students will be able to, number 1, define the term natural disaster. You can tell now we're always starting with the definition, right? And then recognize the world's top 5 worst natural disasters during the past 50 years. We'll also recognize that during the past 50 years, most of the worldwide impact due to natural disasters has occurred in Asia. We'll also list the top 3 natural disaster hazards worldwide over the past 50 years with the highest impacts. In addition, we'll also describe patterns of worldwide disaster-related morbidity and mortality for each natural disaster hazard. We'll recognize the health consequences and characteristics of natural disasters, and we'll recognize 4 different approaches to classify natural disasters. Finally, we'll recognize that weather-related hazards, natural disasters, these comprise the majority of impacts of natural disaster worldwide. First off, the definition. Definition of a natural disaster is a disaster that is caused by naturally occurring hazards. In other words, those hazards that occur in nature. So let's talk about those 5 worst natural disasters over the past 50 years because there's a good lesson within each one of them. The worst natural disaster over the past 50 years was a cyclone that occurred in Bangladesh in 1970. 300,000 people lost their lives, most of them in 1 or 2 days. So how did that happen? Why did we have such an enormous loss of life? Several different factors going on. Number 1, a typhoon, of course, otherwise known as a cyclone or a hurricane. Those all mean the same thing. They're just named according to different places in the world. So there was a cyclone in that particular area, but also there was a delta. Now, river delta is a river that then when it gets to the coastline, it spreads out into multiple little smaller rivers and then reaches down and hits the coastline. Why is that dangerous? Well, first off, people like to live there because it's very fertile land. Number 2, it's very low-lying land, and you're not very far from a river on both sides of you. Because the river splits there down at the delta, you have rivers on both sides, and people live in the land in between. Now, when a cyclone comes into land, of course, and strikes the land, it pushes up a lot of the ocean water, floods the land there. It also rains down upon that area. So you have this double whammy in a cyclone situation in a delta, where now low-lying land, lots of people in that low-lying area, and then now floods occur. And that's a bad combination. But in Bangladesh, that was even worsened by the fact that many of those people were poor. Poverty is an extremely important factor when we're talking about morbidity, mortality, and other disaster-related effects. As a matter of fact, poverty may be one of the most important factors. There's a saying by the United Nations that says, disasters seek out the poor and bind them in their poverty. You know, that's not a coincidence. In every society, every culture, it are the poor people that suffer the most brunt of disasters. So we really have to think in terms of that. When we see delta, poverty, and cyclone, those 3 in a combination really do make a big difference. And that's what happened in Bangladesh in 1970. Bad mix of these various factors. The second worst natural disaster during the past 50 years was an earthquake that occurred in China in 1976. This occurred in a city called Tianjin, and Tianjin was predominantly brick. And unreinforced brick masonry is a bad deal when you're talking about earthquakes. So what ends up happening is these bricks are all dependent upon gravity to stay in line. And when the earth shakes a little bit, the bricks fall over. And that's what happened in 1976. The sad thing is 250,000 people lost their lives because of this particular earthquake. It's a remarkable loss to humanity when something like that occurs. So we have to think in terms of what are we building our houses and what are we building our buildings that are our workplaces and so on. What are we building our communities of? And that was the bad combination. In addition, also, people in that area didn't have a lot of money. So this mixture of bad housing, inappropriate housing for that particular seismic code, that was the combination that was deadly in that particular event. So now the third worst natural disaster during this period of time is the earthquake in Haiti in 2010. And many of you can remember this as well. A lot of similarities when we're comparing Haiti to this 1976 earthquake in China. Why? Mostly impoverished or relatively impoverished population. In addition, also the building structures, unreinforced brick masonry in Haiti. So that's what caused this 223,000 people to lose their lives so abruptly in Haiti. Earthquake zone, in addition to impoverished population, in addition to substandard building practices. All three of those things combined together, that's when you see this large loss of life. So also as well, the next one, number 4, the fourth worst natural disaster in the past 50 years was the Indian Ocean tsunami. Now, many of you may recognize and remember that particular day. 165,000 people lost their lives, and that's simply an estimate because this happened in multiple countries. Once again, why so many people? It's because it had such an expansive reach across the globe. Affected many of the areas of Indonesia, Thailand, Sri Lanka, all the way to Africa. People even died off the coast of Africa, thousands of miles away because of this particular tsunami. So that's why it was so deadly, is because it had such a large reach. I went to that particular disaster in 2005, shortly after it happened. If you recall, it happened right at the end of 2004. I got there right at the beginning of the year, walked in there, and what I saw was just remarkable devastation. I could get in a plane, fly for several hours, get out of the plane, and still see that same level. It was really a very remarkable event to see. So the fifth worst natural disaster during that same period of time was the cyclone in Myanmar in 2008. Had a lot of similarities to the cyclone in Bangladesh. In Myanmar, 138,000 people lost their lives for predominantly the same reason. They were in a delta region. The typhoon came in, otherwise known as a cyclone or hurricane, depending upon where you live in the world. In that particular part of the world, they call them cyclones. This cyclone came in and hit land, and it pushed up floodwaters off of the ocean into that area. In addition, cyclones drop a lot of rain, so they dropped a lot of rain in that area. Now, a delta is where a river comes to the coastline and then it splits into multiple tributaries. And when it did, people that living in between those rivers were captured on both sides. River coming up on one side, river coming up on another, and therefore it creates this large area floodplain. It actually can reach many hundred miles inland, and that's what happened in Myanmar in 2008 when 138,000 people unfortunately lost their lives. So with this slide, I want to share with you the natural disasters by world region. In particular, I want you to appreciate the fact of how much of the natural disaster burden lies squarely in Asia. You'll see on the column on the left is basically percentages, and going across the bottom are the different aspects of disaster consequences. Number of people affected, damages, number of injuries, numbers of death, and so on. So I don't want to get into too much of the detail, but what I want you to appreciate are these different areas of the world. For example, the Pacific, otherwise known as Oceania, up at the top with dark blue. Europe in green, Asia in gray, and the Americas, North America and South America in lavender, and then also Africa in the light blue and below. And you can see here for many of the different factors, and not only just one or two, but multiple factors, Asia has the overwhelming largest area. And the more area in this graph represents the more of the disaster burden. I also want to point out as well in North and South America as well, the Americas, you can see that there are several different spikes here as well, and damage costs and several other factors. So we have to recognize also that the Americas also are disaster prone and have quite a bit of disaster burden overall. So to summarize, I want to going back to the numbers and kind of capsulize this for you, right? So top 5 deadliest natural disasters have involved 2 tropical cyclones hitting poor populations living in river deltas, 2 earthquakes hitting highly populated cities with poor construction, and 1 tsunami hitting multiple nations. And finally, that Asia has suffered the highest impact from natural disasters. In this figure, I want to talk about the percentage of natural disaster deaths worldwide and look at that according to hazard. And there's some kind of surprising things as well. So these are the disaster deaths in a 50-year period, and you can see the majority actually occurred due to drought. And then secondary earthquakes, and then third, of course, are the storms. So is this kind of counterintuitive for you? Would you have thought that most of the deaths, the majority of deaths, or the largest percentage of deaths were due to drought? This is kind of surprising, and it's why we need to take that deeper dive into these numbers to kind of appreciate that drought is actually a relatively deadly occurrence. Now here's a figure of the percentage affected by natural disasters worldwide. So these are people that are an overall number affected. And you can see floods make up a very large percentage of this, droughts second, and then also storms third. Those storms are mostly cyclones, or otherwise known as hurricanes and typhoons. Here's another representation of the percentage of people displaced by natural disasters during that same period of time. Floods about 52%, storms also a very significant factor. Percentage of natural disasters that caused injuries. Overall, we can see cold wave actually surprisingly high. Now, of course, earthquakes a little higher than that, but you can imagine the number of disaster injuries of earthquakes. So for me, that wasn't a big surprise. But didn't you find it surprising that actually the cold waves caused this high number of injuries when we're comparing this to other disasters, and even more so than floods and actually even cyclones as well? So to summarize, floods affected the most people, 51%. Floods displaced the most people, 52% of all natural disasters. Droughts killed the most people at 42%, and earthquakes injured the most people at about 33%, or about a third of all these injuries. So in this next figure, I want to talk a little bit more about the average number of deaths per natural disaster event worldwide. And you can see overall that tsunamis are the big problem when we're talking about numbers of deaths per event. One tsunami event can cause a large number of deaths, almost double second place here. Over 7,000 deaths per event in this average in the tsunami during this period of time, compared in droughts of about nearly half of that. So now let's look at the worldwide mortality rate. And remember that mortality rate is the number of deaths per 100,000 people. So we can get an idea of just how dangerous, how deadly these particular phenomena are. And you can see overwhelmingly that tsunamis are the most deadly here. Over 13,000 people per 100,000 people are expected to die. That's a very high mortality rate, and not many things are that deadly. Second, actually kind of surprising, are heat waves. 3,231 people per 100,000 people, second only to tsunamis. So it's remarkable how high that mortality rate is for heat waves. Now let's look at that death to injury ratio. Remember, this is comparing deaths to the number of injuries, so the number of deaths per injury. And we can see here that tsunamis, 4.9 deaths for every injury, so much higher rate of deaths than injuries. Landslides are second at 3.6, and actually volcanic eruptions third at 2.5, followed by heat waves at 1.7 deaths per injuries. In other words, there are more deaths per injuries. So that tells us that it's 5 times more likely that you will be killed in a tsunami than injured. Doesn't mean that it's not dangerous. It just means that it's even more dangerous when you're talking about death rates as compared to injury rates. So it's a phenomenal occurrence when you see this high of death rates compared to injury rates. Now let's look at that injury rate, for example, for people affected by natural disasters during the past 50 years. Surprisingly, cold is the number one for during this period of time. We also see that heat waves as well as tsunamis, also number 2 and number 3. So we're really talking about high injury rates when we're talking about the rest of these. Now we can see earthquakes actually come in fourth. Kind of surprising. So we should really need to recognize that cold waves in particular, surprisingly high. Heat waves, surprisingly high. Of course, we would recognize that for tsunamis. We'd recognize that for earthquakes. But we have to take a second thought when we're talking about a high injury rate for these other 2 types of weather-related disasters. Now let's talk about that rate of displacement. Once again, the number of people displaced per 100,000 people affected. And we can see, of course, that tsunamis also have the highest in this regard. Landslides number 2, and then third, earthquakes. Now remember, geological disasters are those that affect the movement of the earth, right? All 3 of these are related to that. So it kind of makes sense, doesn't it? Landslides, tsunamis, earthquakes, all of them destroy homes. When people's homes are destroyed, they're displaced, right? So it really makes some sense when we're talking about these kinds of figures. It's a way to kind of put the numbers in context so we can remember them easier. So to summarize, during the past 50 years, tsunamis killed the most people per event and per 100,000 people affected. Tsunamis, landslides, volcanoes, and heat waves killed more people than they injured. Cold injured the most people per 100,000 people affected, followed closely by heat waves and tsunamis. And also, tsunamis and landslides displaced the most people. Now I want to take a little bit deeper dive into this issue of health consequences of natural disasters. Remember, we did that one large, very busy table with red, yellow, and green. And we listed that gray column over on the far left, remember, where all the public health consequences of all disasters were. And we can recognize the same thing here when we're talking about natural disasters. Natural disasters cause all of these public health consequences again: deaths, injuries, loss of clean water, loss of shelter, loss of personal goods, major population movements, loss of sanitation, hygiene, solid waste management. There's a high public concern for safety. There's increased pests and vectors and damage to the healthcare system. There's worsening of chronic diseases and loss of electricity, toxic exposures, and also loss of food supply. And once again, it's not necessarily that each disaster is exactly the same when we're talking about natural disasters. Each of them vary to a certain degree, as we'll see in this next table. So this particular table looks at the causes of death from natural disasters. And let's take a deeper dive into that, because it's really important for us to learn what are the causes of death. Because as we've learned, much of this particular seminar and this presentations is we're really looking at trying to prevent these deaths, right? We can't get those folks back once we've lost them. So we really have to think about preventing that. And understanding this cause of death for each disaster hazard is really important. So for example, many of us know about that drought-famine cycle, right? That drought causes famine over a period of time, and therefore we have malnutrition as being the number one cause of death for droughts. But also, what many people don't know is actually infectious diseases are associated with droughts as well. These outbreaks and epidemics that occur as a result of drought. As a loss of water, people lose the ability to shower and wash their hands and to clean surfaces and so on, to be able to use the proper sanitation methods. And so therefore we see these outbreaks of infectious disease associated with drought that take just too many lives. Now with wildfires, one thing of course we would think of is, burns of course, but strangely enough, the number one cause of death in a wildfire isn't necessarily burns, it's actually smoke inhalation and asphyxiation, in other words, suffocation from that smoke. Now we also see burns of course as being a very high cause of death as well, and also toxic exposures. When people breathe in that smoke, they breathe in these toxic materials and also lose their life because of that. So we have to think in terms of that smoke being deadly, not only the fire. In heat waves, many people, and the majority of people, die from heat strokes. That's when your body gets too overheated, it can't cool itself down, and therefore you pass away from that. But also we see exacerbations of cardiovascular disease. In other words, worsening of strokes, worsening of heart disease. Those also contribute to the deaths in heat waves, and many times are relatively remarkable at the number of deaths that these can cause. And because the elderly predominantly have these diseases, strokes and heart disease, older folks tend to have more than younger folks, the heat waves tend to affect older people more than younger people. So therefore, once again, knowing what those causes of death are, we can prepare ourselves to be able to prevent those deaths from occurring before they do. Or when the heat wave starts, we can start heading this off, getting ahead of the problem. The other thing that may be counterintuitive is actually tropical cyclones. Drowning is the number one cause of death in a tropical cyclone, and most people would think, wow, actually I thought it was the wind. But I say it's not the wind, it's actually the water that kills people in cyclones. So how can we protect people from that? Well, we get people out of flood zones. We get people away from the coastlines, we get them away from the rivers, we get them away from these areas that can flood easily, and therefore we protect them from this number one cause of death. And the second cause of death, the second highest cause of death in tropical cyclones, is actually traumatic injury, but this is weird. It's actually not during the disaster itself, not when the wind is blowing that most of these traumatic injuries occur, but actually afterwards, 2, 3, 5, 7 days afterwards, when people are doing cleanup. They're trying to do recovery. They're trying to fix their roofs, so they're up on the roof using a ladder, walking around on a roof that they've never done before. Or they may be using a chainsaw, which is a dangerous tool in itself, and they've never used a chainsaw before, and many times those are the causes of death. Or people may be walking around live wires, electrical wires and so on, and electrocution, or cutting down trees and those kinds of things and have problems. So falls and these other kinds of issues then become the problem. Traumatic injury then becomes a problem, but oddly enough, 4, 5, 7 days afterwards. Is that preventable? Absolutely. All of these things are related to safety, related to training, related to getting people aware of this problem. So many of these things, so many of these disaster-related deaths are preventable, and that's why I want you here with me. I want you to be the expert, to go out and share this with other people. I want you to teach this message so we can lower these death rates. We really need to be able to get ahead of the problem. And also now tornadoes, when we look at tornadoes and floods, it's a little bit more intuitive. Tornadoes, number one cause of death, traumatic injury. Debris driven by the wind hits people, causes them to become injured. As a result, they succumb to those injuries. Same thing with floods. We're looking at drowning. Yes, of course, that's what you would expect to happen in a flood, is the most common cause of death to be drowning. And earthquakes and landslides are very similar in the aspect that number one cause of death is traumatic injury. Earthquakes, of course, buildings and other things that collapse and hit people and so on. And there's a saying in earthquakes, we say, earthquakes don't kill people, buildings kill people. It's the collapse and the falling of debris, or maybe even things like chandeliers or pictures on the wall or bookshelves or things that are in cabinets and so on that fall on people that cause those traumatic injuries in an earthquake. And landslides, of course, it's the falling dirt, isn't it? It's the landslide, the debris flow that comes down and hits people, carries rocks and dirt and trees and all so on, and those cause traumatic injuries. But the interesting thing about both of these is that they also cause asphyxia. In other words, suffocation is the second most likely cause of death in these examples. Now, why is that, you may ask? Well, it's because when these debris come against someone's chest, when you're pinned down against the ground and a lot of heavy weights from either this earthquake or from this landslide debris press against the chest, and when you exhale, your breath goes in. And now you don't have the strength to push against all the weight of that debris. So now you can't inhale more. Every breath that you let out, your chest becomes more compressed. And therefore, we see suffocation in both of these examples. In volcanic eruptions, we see traumatic injuries, of course, from flying debris. When these volcanoes fly off, rocks and other kinds of things come flying into the air, many times for very long distances. And so people can become injured from these. We also see burns from fires that are started from volcanic eruptions. And we also see people that are affected by toxic exposures. So that tephra, which is it's the fallout from volcanic eruption, when you see that smoke and those type of gases that come out, they not only carry dust and debris and so on, but they also carry toxic chemicals that can expose people to particular dangerous chemicals, and therefore those folks have problems with these toxic exposures. And not only by breathing it in, but also by their gardens and by their water sources and so on. When this stuff settles on the ground, it can poison a garden, it can poison fruit trees, it can poison water supplies and so on, and then people ingest that without knowing. They may not get all that cleaned off and therefore have these toxic exposures. Tsunamis also cause drowning, but we also see these traumatic injuries, and it's hard to tease this out, which comes first, the drowning or the traumatic injury. Why is that? I like to compare tsunamis. I say, it's not like a flood. A tsunami is like a freight train. It's like a bulldozer that comes rolling through. And so you're not only drowned by the water, but you're mixed in this debris. Trees and homes and bricks and glass and telephone poles and pieces of concrete and all this stuff rumbling through inside that water. Tsunamis have a tremendous force behind them that carries a lot of debris. And people get caught up in the water, but they get caught up in that debris. And so therefore, this mixture of traumatic injuries and drowning are really very sort of a double whammy when we're looking at this tsunami-related deaths. And finally, cold weather, also a little bit counterintuitive as well. So we really need to pay attention to these. Of course, cold weather, the number one cause of death is hypothermia. In other words, it's the cold. The body temperature drops, gets too cold to sustain life, and people succumb to that. But also asphyxia, in other words, suffocation also is another cause of this death. And what we see is that actually people use carbon monoxide emitting sources for heat and for cooking. So how does that happen? Well, cold weather, many times ice storms and so on, they knock out the power supplies. People may need to heat their homes, or they may need to cook their food. And they kind of get ingenious. Well, I think I'll bring in charcoal. I'll bring some charcoal into the house. I'll cook there. I'll use these other types of devices, either kerosene heaters or other types of fuels, and heat inside the home. But what they don't know that they're doing is they're actually bringing in these devices that then give off carbon monoxide. And when carbon monoxide goes into the atmosphere inside an enclosed space, it replaces the oxygen. And we start breathing that in instead of oxygen. And that's how people get poisoned and they suffocate because of this. So you're breathing in this carbon monoxide, this poisonous gas. And that tends to be the number one cause of death after this issue of hypothermia. So we're really talking about number one and number two being a real big problem. Number one, of course, hypothermia we can recognize, but not everyone recognizes this threat of carbon monoxide. So please, totally preventable. Help me spread that word. Now, this is that one table I was telling you about where the public health consequences in gray on the far left column, and then the others as well for the different natural disasters. We're just looking at natural disasters. And red are the most severe problems, yellow or orange are the moderately severe, and then green the least severe as well. Now, I do this not to look at the individual things because I know this is a busy slide, but I want you to see the pattern here. What we're really talking about is all these natural disasters cause all these public health consequences. So we really have to think in terms of trying to be able to treat and assess the needs caused by all these public health consequences for every disaster. If you can do that in that one column, that one gray column, you can now affect change in all these other types of disasters. Some have more than others. So for example, earthquakes and tsunamis certainly have more injuries than, let's say, hurricanes. However, both of them have injuries. But so if we can treat injuries and large numbers of injuries, now we can start addressing each one of these natural disasters. That's called an all-hazard approach. And that's what we need to think about when we're talking about protecting ourselves. Finding those activities that reach for all disasters, identifying those hazards that we face, and then applying it to each one of those one by one to protect ourselves and prevent any types of these injuries from occurring. Let's talk in terms of now general ways to classify disasters, and there are four main styles. One of them is this classification based upon time, which is slow or fast onset disasters, and we'll talk more about that. In addition, also based upon the presence of an advance notice. So we say advance notice or no notice. Also based upon the size of the response necessary, emergency being the smallest, disaster being the middle, and catastrophe being the largest. And then the next as well, based upon the type of hazard, natural, technological, or hybrid disasters. So this time-based classification of natural disasters, we can break this into two main categories, slow onset and rapid onset. It really makes a big difference because we're talking about our ability to prepare at the last minute when we look at these slow onset and rapid onset. So slow onset disasters, a couple of examples, are river flood. River flood, the rain occurs over a longer period of time. The river continues to rise. We can measure those crests and each day and tell if the river is continuing to rising. And then finally the river breaks its banks and floods the area. But it's a slow onset phenomenon that we have time to prepare, think about getting people out of that dangerous area. Droughts are very slow onset disasters as well. They tend to occur over a period of time, usually in years. So it starts getting dry, worse each year, miss a rain season and so on, and now you're into drought situations. But people can prepare for that if they have an early warning system and know that's coming. Epidemics can do the same thing as well. Of course, not all epidemics are slow onset, but many of them can be. You start off with a few cases, a handful. Those turn into 10, 20, 100, then 1,000, and so on. But relatively slow if we're comparing those types of slow onset disasters compared to these rapid onset disasters where like flash floods and storms and earthquakes. So a flash flood is different than a river flood. A flash flood usually occurs when it rains into a mountain area and then there's a ravine or a very narrow valley and all that water goes through that valley very quick. Many times people don't even see those things coming. So there's a higher loss of life with flash floods as there are with river floods in most cases. In addition, certain storms also are rapid onset. For example, like a tornado. A tornado can form out of a funnel cloud within a few minutes. Touches the ground, starts doing destruction right then. So this idea of having a rapid onset warning system is a very big challenge, and certainly that's one of the major successes in tornado prevention, in preventing those injuries, is to be able to have that early warning system. And then also earthquakes, very rapid onset, right? I mean, nothing at all, going about your business, then all of a sudden everything starts shaking immediately. In many cases, you can only walk so far, 2 or 3 steps before you're unable to walk any further in these events. So we really have a lot of ground shaking, and this rapid onset really gives you very little time to be able to take any type of protective action. So now let's take a closer look. Let's take a deeper dive into these slow onset disasters because there's a lot to learn here, right? 46% of natural disaster deaths worldwide over the past 50 years were slow onset disasters. Drought with 42% of those. And epidemics also another significant component of that as well. What does that mean for us? Well, what that tells me is nearly half of all disasters, this slow onset, we have the ability to prepare. Many times while the event is actually occurring, we can see it starting. We have time to get in there and start trying to make a difference. And certainly that's what we're doing for the Ebola outbreaks in Western Africa, right? We see the beginning of it, it starts spreading, getting out of control, and the whole world really went to Western Africa to try to make that intervention. Slow onset, let's prevent it, let's stop it there. So that's the idea here as well we should be doing with all these types of disasters. And if half of all disasters, 46%, half of all disasters have that slow onset, let's get on board. Let's make a difference in this kind of thing as well. So I just wanted to show you that opportunity that we have with these slow onset disasters if you look at the 50-year period. Now, we talked before about this notice-based classification of natural disasters, advance notice and no notice, right? And we talked about river floods and how, we get this sort of a slow onset, or you get some notice that it's going to happen. Tsunamis also, we have a notice as well. Tsunamis, we have an advance notice, and that's where early warning systems in tsunami are so important. And they've set those across the entire Pacific region, and now there's a development of an early warning system in the Indian Ocean for the same reason, right? So that we can have this advance notice, people can get out of the way. So the same issue with river floods. We know the river's rising, we want to get those populations away from the water, get them away from this particular problem, this particular hazard, so that they won't be affected. And we can do the same thing with tsunamis as well. Tsunamis travel very fast. They travel 500 or 600 miles per hour. But even that, with a large expansion of the ocean, we still have many hours in many cases for time. So for example, tsunami that may occur in Japan, actually, if you get in a plane in Japan and you fly to California, right? It takes 8 or 9 hours to get there, so much traveling at 500 to 600 miles per hour. That's the same speed a tsunami travels. So when an earthquake occurs on one side of the ocean or the other, you have some time to get those populations away. You have advance notice once you know the event is actually occurring. And that's an important life-saving measure. It's these no-notice events where we really have to start thinking much more in advance. A flash flood, for example, where it comes through a valley very quickly, people may not have any notice whatsoever. Boom, the water's there. Or you may have 1 or 2 steps in an earthquake before you can fall to the ground because you just can't walk with that much movement. And in that case, there's really not much more you can do. Once that earthquake starts, there's no notice. So we really have to think in terms of flash floods or earthquakes, preventing that from ever injuring us long before it ever starts. This advance notice and no notice makes a big difference in our survivability of these natural disasters. So let's look closely at those natural disaster events that are associated with advance notice. 68% of natural disaster deaths worldwide over the past 50 years were advance notice. That's 2/3 of the disasters that occurred in the past 50 years. We had an advance notice and knew they were coming. We knew that, droughts were on the way. We knew that tsunamis were on the way. So it's this early warning system and recognizing this and then doing something about it. So what I'm giving you is some information about the opportunity here. If 2/3 of all disaster deaths in the past 50 years were something that we had an advance notice for, can't we be better positioned in the future to be able to make a difference once we have that notice? And that comes with monitoring the hazard. That comes with then acting upon it and warning the population. And then also, too, what I'm doing with you now, educating you on what to do once you get that warning. Because it's one thing to receive a warning for tsunami or receive a warning from some other type of hazard, but you have to know what to do. I can tell you from my own personal experience, I lived through a tornado, as many of you may know. Some of you may not. And so the way that I saved my life and the life of my family is I had an advance warning, and I had messages that I had learned long before, even as a child, that actually I knew what to do when I got that warning. And when that occurred, that saved my life. It saved my wife's life. I wouldn't even be here now talking to you if it weren't an advance notice and also the education that I had received. So it's not all about early warning, but putting those things together, early warning and advance notice of these events, that's a really strong combination for saving lives. And boy, that's why we're here, isn't it? We also have this hazard-based classification of natural disasters. I touched on that in one of the early sessions here in this particular seminar. We have hydrometeorological, in other words, related to weather, geological, related to the earth movement, and then biological, related to infectious diseases, right? And those examples of hydrometeorological natural disasters related to floods, cyclones, storms, droughts, hot and cold waves, as well as wildfires. Examples of the geological natural disasters: earthquakes, tsunamis, volcanoes, landslides, and avalanches. And then, of course, the biologicals, the living disasters. Biological disasters include epidemics and pandemics on a global scale. So I want to talk more about that hydrometeorological or weather-related disaster, because I think there's a lot of concern here that we have to think about, not only in the past 50 years, but also in the future. And I want you to join me in that charge and that call to action to really do something about these disasters. These weather-related disasters caused 73% of all natural disaster deaths worldwide during the past 50 years. 73% were weather-related. Drought, storms, floods, and so on. Significant number of deaths just due to the weather. Why am I so worried about that? Well, number one, weather we can monitor. We can sometimes forecast weather into the future, so therefore it turns it into an advance notice. It turns some of these into a slower onset disaster that we can take some preparation ahead of time. Also, we know whether we're prone to these particular weather-related disasters. So, for example, in the United States, the northern United States has states like Iowa and Michigan and places like that, way up in the north, right? They're not close to the ocean, nowhere near hurricanes. So people there don't have to worry about hurricane weather. But if you live in the coastline, whether it's the United States, whether it's the coastline of India, whether it's the coastline of Bangladesh or other areas in the Caribbean, if you live on the coastline and you're in an area that's affected by typhoons or cyclones, you should be making those preparations. So weather-related disasters gives us the ability to predict the future, forecast it, and be able to make a difference in our survival rates. And the other aspect of weather-related disaster is very important, and I want to share this with you now. Think about this very closely. Weather-related disasters are going to worsen in our lifetime. They're going to worsen in our children's lifetime, and they're going to worsen in our children's children's lifetime. How do I know that? Because climate change is real. It's happening already. I've been watching it, been responding to it for many, many years. I've already been to disasters involving sea level rise many years ago. So seeing this worsen over time, we should be able to say, look, weather-related disasters are a high priority in the future, and what we have to do, if 73% of natural disaster deaths are weather-related, we really need to get a handle on this particular aspect of natural disaster. So I want you to join with me in doing just that. Now let's look at this issue of 97% of people affected by natural disasters worldwide were the result of weather. 97% of all natural disasters worldwide, all weather-related, and we're talking about that worsening? So that's the big issue. That's the gorilla in the room that we have to think about, weather. And once again, floods, droughts, storms, those are the big killers, right? So we need to be thinking in terms of what we can do when more people are affected, when more people are displaced, when more people are injured. Getting a handle on those are very important for the future for us. And now 84% in the past 50 years have been displaced by natural disasters. Once again, these related to weather. 84% related to weather. That's phenomenal. Half of those actually related to flood. A very large component of those as well related to storms. So once again, we really have our work cut out for us, but we know where the charge is. We know where that call to action has to occur. Really need to focus on natural disasters associated with weather because they're becoming more frequent. Over time, as the Earth, they say in the Earth ages very slowly, right? 1,000 years to the Earth is nothing. And actually, over time, these geological disasters, the number of them that are occurring, the number of earthquakes that are occurring, the number of tsunamis that occur, the number of landslides that occur, and so on, many of those are relatively stable. They haven't changed. The number of earthquakes hasn't changed for thousands of years. But weather-related disasters are getting more and more frequent and affecting more and more people. 84% in the past 50 years have been displaced by these weather-related events. So if something's climbing, that has to have our attention. 66% of people injured by natural disasters worldwide were the result of weather. That's 2/3 of everyone. Cold weather is a big issue with this, as well as floods and also storms as well. So we have to think in terms of also of injuries related to these natural disasters associated with weather. So I want to summarize for you. Worldwide, during the past 50 years, slow onset events caused 46% of natural disaster deaths, and advance notice events caused 68% of natural disaster deaths. That's a pretty significant number. To further summarize as well, during these past 50 years, weather-related disasters have had the most health impact of any other category. Among all natural disasters worldwide in the past 50 years, weather caused 90% of the people affected, 84% of the displacement, 73% of the deaths, and 66% of the injuries. That's the overwhelming burden that we have, are these weather-related disasters.